Hello, this is Mr. Agbamu Idanogwene, and this time around I want to present how you can demonstrate some mechanism in your class using the Geogebra Classic software. This time around, this particular mechanism does not have a particular name like the rotary engine, the crank and slider, the 4-bar mechanism, but it's a good mechanism that you can use depend on your objective, depend on your target, depend on how you want your machine to work, and it can help you. It's just a part of a particular machine. That's why we call them mechanism. Let me import the image so that you can see it. I'll describe it, and from there you can analyze it together. So this is the image. Okay, then this mechanism, I just snapped it from the theory of machine textbook. It's one of the exercises there. Let me describe it so that we can do the mechanism together. You can see in this mechanism we have the link AB. You can see the arrow of rotation. So this is the main driver. This is where the power comes from. So as AB rotates in this mechanism, it transmits power to the link BC. And take note, point A is a fixed link, so that a fixed point here, it does not move. It's only B that moves around about A. Then BC, which is connected to AB, also moves. It carries the power to the link CD. And if you look at link CD, you will see that D is a fixed point here. D does not move also. D is fixed in this place. While E is connected between CD. As AB takes the power to CD, as AB takes the power to BC, BC takes the power to CD, and CD just oscillates. It go to and fro in this order like this, taking this link EF to slide this piston inside this cylinder. So that is how the mechanism works, while the power comes from AB. So a mechanism like this will not really have a particular name, but you can use it in your machine design, in your machine production, depend on your objective, depend on what you are trying to target. But the main aim of this machine is that the first target here is AB will rotate, taking power to CD. CD oscillate, that is one. Then as CD oscillate, it takes the power to EF, which makes this piston to slide in this order. You can see some dimensions are given, so let me follow the dimension and move on. Then each of these members, their length are being given. I have it written beside me on a piece of paper here. I will use them to do it so that it will not take our time. So to start, let's start with the moving with the power source now, which is the AB link. As usual, I get my circle, get my center. Let me start somewhere here. Okay, get my center. Then the length AB, let me get the measurement. AB is 150 millimeter. So I'll be dividing by 100. I'll take a scale of 1 1 cm to represent 100 millimeter, so that I'll be dividing everything by 100. So this is 1.5. So I've gotten my AB. Then let me get my point. So my point B is this, so which will go round. So this is point B. Now we turn around. As it rotates like this, it will transmit the power through BC and the rest. Alright, let's move on. Let me label this point. Just to right click, rename. So this is point A. Then just to right click this, rename it. This is point B. Alright, then the next thing is I need the distance from fixed point A to fixed point D. So you can see the distance has been given from A up to this place. I have 3.75. So let me get that distance, and I'm going to use point to locate that. So I need to get point D, very important. So I'll just count from here. So this is from 0. I have 1, 2, 3. So this is 3.7, should be around this place. Then I'll still move again from there. to this place 3.7, just for me to count 1 2 3. So 3.5 6, so 7 should be somewhere here. I'll move again 1 2 3, so I'm marking somewhere here now. Alright, so take note of that. So I'm getting my point D around this place. Let me leave it somewhere there. Then let's label it as point D. We'll name it as point D. Alright, now my two fixed points, point A and point D, is gotten. So the next thing I need to do now, let me get my BC and my CD link to connect together so that A will be the main driver. So that is a link. AB will be the main driver. So let's start. How do we do this now? I get my circle center B, because B is the one to take the motion. So B will be my center. Then I need to measure BC now. Let me get the length of BC from my paper. So BC is 450. So get my center as B. So 450, which is 4.5 radius. Okay, get that. Then the next thing, B is going to intersect BC and DC. They intersect at this point, so I need another circle from D, and the radius of CD here is 300, which is just 3. I'll divide by 3, and that is this. Alright, let me be sure this length. Am I sure I measured this one very well? Let me check it again. Okay, sorry, I used the measurement of DE. So I said DC. Let me get the measurement of DC. Okay, DC is not given directly, but they gave DE and CE. Let me add them. That is 300 plus 150, which is going to give me 450. So my DC radius is 450, that's 4.5. Alright, so this is it. I've gotten this. Then you click. Then I need the point of intersection between the two circles, which is this and this. So this is my point C. Gotten now. Is it point C now? Yes, this point has been gotten to be this place. So let me hide every other object, hide all the objects I don't need. So just to right click the ones you don't need and click on show objects. Okay, then now let me connect those ones that I have now. Get my segment from A to B, B to C, C to D. Now let me label my point C. Just to right click, rename, call it point C. Okay, so let me check if it's going to work as we want. Remember, the analysis is as AB rotates, BC takes the power to CD, and CD oscillates in this order. Let me turn it and see. So okay, it's being gotten. We got it. So as B rotates, and then CD will oscillate, and that is what is happening here. So I've gotten this. The next one is, let me locate my point E. So my DE radius here is 150. So I need to get my circle of center D, and that is 150 millimeter, which is 1.5. Okay, so this is where E will be. Then I need to get my point of intersection between this circle and this line, and that is my point E. Let me hide this one, show object, then label this point as rename as point E. Okay, it's already called E, so I'm in order. So this one, so point E, we now transfer the motion now to through EF. We now transfer the power to the piston that will slide along this line. So what I need finally now is to get this distance from point D down, which is 100, to get the line of my slider. So that will not take time to do. I just get my line from here. 100 is just 1 now. So on this line, I click this, I go straight. Okay, that is all. Now, so my slider is going to slide on this place. Then my point, how do I get point F now? I need circle again. If you discover in this my mechanism analysis, circle is one of the major things we use. Circle with radius. So EF is 350. That's 3.5. Okay, get your point of intersection. Circle on this line. Okay, so point F is gotten, which is where the piston will slide along this line. Then hide the circle we don't need. Right click, show object. I don't need this line also. Show object. I don't need this. Show object. Don't need this. Show object. Don't need this. Show object. Then we'll label this as F. So this is my point F. Okay, then let's join it with our segments. So E to F. Then let me make my small slider here. Let me just get a small circle of, let me say 0.5. Okay, alright. Let me just make a small polygon here to represent my slider. It may not be a perfect rectangle, but at least it can represent what we want. Okay, then we can hide whatever we don't want now. Show object. All the lines we don't need, just hide them. Okay, so the mechanism is done now. All we need to do is to play it and to test it. So this is point F. Let me put this point, let me put a trace, show trace. So this is the mechanism, complete and done. AB rotate, takes the power through BC, and CD oscillate, connecting to point E, E to F, and F makes this piston to slide along this cylinder, which is what will happen now. So let me just move it before I play it. See how it works. So this is the mechanism. Very easy. There are so many mechanisms in mechanical engineering, and to do that you can do it with Geogebra classic software so that you can monitor it and know how it works. Let me animate it so that we'll watch it and see how it works. Okay, in the paper here it's supposed to be clockwise rotation, but my own is going anti-clockwise. So let me stop it. I need to right click, go to setting, under algebra, then I need to choose decreasing. Okay, let me see if I can increase the speed to 2. Okay, alright, so this is the mechanism. See, as AB rotate round, CD oscillate, then E is connected to F, and it makes the piston to reciprocate inside this cylinder. So that is the mechanism. So let me hide this circle, show object, and let's play it again, and you see the mechanism. So this is the mechanism, how it works. You can demonstrate it with your students when they see it on paper like this and they don't understand how it works. With this analysis they will see how it works, and the understanding will come out easily without any stress, any problem. So I hope you enjoyed this video. Thank you for watching, and do have a nice day.